Hey Math fans! Welcome back to Math Olympiad Academy, your gateway to advanced problem solving and mathematical reasoning. In Lesson 13, we tackle a trapezoid that looks complicated at first glance, but becomes simple with a clear, step-by-step approach. Our goal is to determine the area of a trapezoid, also known as a trapezium, using an efficient and helpful method. Let ABCD be a trapezoid, as shown. The bases are AB equals 40 centimeters and DC equals 65 centimeters. The legs are AD equals 30 centimeters and BC equals 25 centimeters. The question is, find the area of trapezoid ABCD. Before we begin, here is a quick note. Some students drop perpendiculars and apply the Pythagorean theorem. While this approach is correct, it leads to quadratic equations, making the calculation long and tedious. Instead, let us recall the area formula for a trapezoid. The area is defined as the sum of the two bases, multiplied by the height and then divided by 2. We know the lengths of the two bases, AB and DC, but the height, h, is not given. This is the key step, so let us find the height. To avoid using perpendicular projections and the Pythagorean theorem, which would lead to quadratic equations and a lengthy solution, we apply a clever geometric construction. To find the height efficiently, draw a line through point B parallel to side AD. This line intersects base DC at point K. This construction creates triangle BCK. Because the line through B is parallel to AD, the segment KC equals DC minus AB, which is 65 minus 40, or 25 centimeters. So triangle BCK has 3 sides. BC equals 25 centimeters, KC equals 25 centimeters, and BK equals AD, which is 30 centimeters. Now, we apply Heron's formula. First, compute the semi-perimeter, denoted S. S equals 25 plus 25 plus 30, divided by 2, which gives S equals 40 centimeters. Next, apply Heron's formula. The area of triangle BCK equals the square root of S times S minus A times S minus B times S minus C. Substituting the values, we find the area of triangle BCK is 300 square centimeters. Now, let us extract the height h. Triangle BCK has base KC equal to 25 centimeters, and its height is the same as the height of the trapezoid. Let's call this height h. Using the triangle area formula, 300 equals 25 times h divided by 2. Solving this, we get h equals 2 times 300 divided by 25, which gives h equals 24 centimeters. So, the height h is 24 centimeters. In this final step, let us compute the area of trapezoid ABCD. The area of a trapezoid is given by the sum of the two bases, AB plus DC, multiplied by the height h, all divided by 2. We know AB is 40 centimeters, DC is 65 centimeters, and the height h is 24 centimeters. Substituting these values into the formula, we get 40 plus 65 times 24 divided by 2. This simplifies to 105 times 12, which equals 1,260. In conclusion, the area of trapezoid ABCD is 1,260 square centimeters. I hope you enjoyed this step-by-step solution. Keep practicing, share this lesson with your friends, and don't forget to subscribe to Math Olympiad Academy for more exciting math challenges. See you in the next lesson!